Okay guys, so let's go over yesterday's lesson real quick. Basically what we were dealing with was we started off wanting to just do some basic XY charts, so I'll just do the first one real quick, then we'll move on from there. But this first one, we would have to just complete our XY chart, which we did like this. There's my X, my Y-intercept goes here. Then this would be +2, +3, which means up here would be the opposites. So as I'm going in both directions, I'm just following my rule. So 27 plus 2 is 29, plus 2 is 31. Okay, 0 plus 3 is 3, plus 3 is 6. 27 minus 2 is 25, minus 2 is 23. 0 minus 3 is -3, minus 3 is -6. Okay, and then we went through, I think we went through the third one in class together, so you should have had those in your notes, but if not, just complete them on your worksheet, you'll be fine. Okay, our goal this week is that we could solve systems using substitution, so we're learning a new concept. Okay, so we've been solving using multi-directional XY charts, and those have looked like this. So to solve this solve this system using my multi-directional XY charts, I've just drawing out my charts. XY, XY. The slope on this one is going to be the opposite of A over B, which in this case is the opposite of -1, which is +1 over B, which is 3. And then my Y-intercept is going to be C over B, which in this case is -9 over 3 or -3. So I'm going to throw my Y-intercept right there. I'm going to put my slope down here, it's always y over x, so +1, +1, +3. So up here would be the opposites. Now my y-intercept for this one is +3, and then my slope is -5, which is my y, over 3, which is my x, and then my opposites would be here. Okay? And then I just follow my rules. 3 minus 5 is -2, -7, -12, 3, 6, 9. Going this way, it'd be 3 plus 5 is 8, 13, 18. 0 minus 3 is -3, -6, -9. Going down here, -3 plus 1 is -2, -1, 0. This would be 3, 6, that would be 9. Going backwards here, -3 minus 1 is -4, -5, -6. 0 minus 3 is -3, -6, -9. Okay, now to solve it, all I have to do is find a matching coordinate. And if I look through all my coordinates on both sides, the only ones that actually match are right here, which means that's going to be the solution to my system. So I would write it as x equals 3. My x column equals 3. My y column equals -2, and I'm done. So that's what we worked on all last week, was just how do we solve using multi-directional XY charts. Okay, this week it looks a little bit different. So if I gave you a set of equations or a system of equations that look like this, what you're probably going to be doing is trying to find slopes and y-intercepts, but however, we already know one of our answers because it's given to us. In this case, it gives us y equals 5. So we know what y equals. So what we're going to do then to solve that is just come to my second equation, because since they're a system, I know they're crossing at some point. And if this is 5, then my 5 value is going to be the same here. So I'm just going to substitute that 5 into my equation, like so. Okay? And then I'm just going to solve it. So I'm going to go 3x plus 2 times 5 is 10. So 3x plus 10 equals 20. Okay, I'm going to move my 10 or isolate my x by taking the opposite. That goes away, and I'm left with 3x equals 10. And then to get the x by itself, I divide. There's 1, and I'm left with x equals 10 thirds. Now I would leave it in the fractional form. I like to leave it in fractional form, just so you stay in the habit of keeping it there. If you want to unmix it, you can, but leave it in fractional form for most purposes. My y, of course, would be 5. Okay? So then, we decided to jump into our phase notes. Knowing that we just did a substitution, we wanted to expand it a little bit more. So we were looking at y equals 6x plus 11, and we were looking at 2x minus 3y equals negative 2. I believe that's what we're looking at. Let me, negative 2x minus 3y equals, I lied, negative 7 is what the one we used in class. And this was a minus 11. Okay, that's what I get for using my memory. Okay, so the first thing we want to do is figure out which equation would be the best to substitute. Luckily, it doesn't really matter which one you use. However, I like to always use the given. So the given in the previous one was the one that told me what y equals. Well, it just so happens I have an equation here that also tells me what y equals. So I'm going to use this as my substituting equation. So that'd be the first one, is identify the substituting equation. It is always the equation in the slope-intercept format. The reason that is because it's telling me what y equals. So that was our phase 1 notes. In phase 2, we just said take that y equals 6x minus 11 and my negative 2x minus 3y equals negative 7. So take that, and we're going to take this guy and we're just going to plug him into that y. So it would look like this, negative 2x minus 3. Now to plug it in, I'm replacing my y, so I'm going to use parentheses. Negative 6x minus 11 equals negative 7. So all I did was get rid of my y value, use parentheses, and took that equation and plugged it in there. That's how you substitute that. Okay? So now I have a substituted equation that looks, we had y equals 6x minus 11, we had negative 2x minus 3y equals negative 7, and I plugged that 6x minus 11 into the y value of the second equation. Now from here, this is where it gets repetitive. It almost always works this way. We're going to distribute, then we're going to combine our like terms, then we're going to isolate by moving, and then we're going to divide, and we're going to have a solution. So what that looks like in real time is like this. We're going to distribute across the parentheses. So now I have negative 2x, negative 3 times 6 is negative 18x, and negative 3 times negative 11 is a positive 33. And all that equals negative 7. So I just got done distributing. Now I'm going to combine all like terms on that side. My x's are like terms, so negative 2 minus 18 is negative 20x plus 33 equals negative 7. Now I'm going to isolate my x value over here by moving this 33. So to move it, I just take its opposite from both sides. That's 0, so it's off that side. And negative 7 minus 33 is negative 40. So now I've distributed, I've combined like terms, I've isolated, and all I'm left to do is divide by my x to isolate that x even more, and I have x equals positive 2, because negative 40 divided by negative 20 is 2. Okay, so I just solved for my x value, but I'm not done yet because all substitutions are coordinates. So we had our y equals 6x minus 11. We had our negative 2x minus 3y equals negative 7. We solved it all the way out, and now we have x equals 2. So now I need to plug that x back into one of these two equations. Now it doesn't matter what equation I plug it into. However, it's easiest if I do the one that's in slope-intercept form. So I'm just going to take this value and plug it in for that x. So I got y equals 6 parentheses 2 minus 11, which gives me y equals 12 minus 11, which leaves me with y equals 1. Now the last thing right here, state your final answers together. I do want you to write them right on top of one another like so. And the reason is there's a lot of math. Look at all this math that's taken place here. We did all this. We did all this. So if you have them too disjointed, it's hard to find out where your actual answers is. So always state them together. That's what we did in class yesterday. We practiced a bit. We had our phase practice problems. So these were your practice problems. Okay? So make sure you get those down on a piece of paper before you turn this in for the makeup work. You can pause this video to get them. And then the last thing we did was our exit task. And all we're doing in this exit task is just solving for x. So we're basically we did the previous steps down to this point. Now you're just going to need to distribute, combine, isolate, and divide. And you got it. Perfect. I hope that was helpful, and good luck getting this makeup work done or catching up on what we had going on in class. Thank you.